you go. Oh, a Stack Overflow error. What happened? Yep, when you change one, the other one fires off, which causes the first one to change, which causes the second one to change, which causes the first one to change. Ew, not a good way to do things here, right? Well, we can fix that. What we can do is add in a little logic to say, if the value didn't really change, don't fire an event. And that seems pretty reasonable, doesn't it? So we go up into our little fire property change method here, and I'm going to say, if the old value was null, if the old value is null, always fire the event. Now, that will actually be a problem with this code if the new value is null as well, because then you'll get your infinite cycle. But I'm going to wave my hand at that for the moment and say, let's not worry about that. If the old value is not equal to the new value, go ahead and fire your change. Okay. We could extend the logic in here saying, if the old value is null and the new value is not null, fire it. Else, if the new value is null and the old value is not null, fire it. Else, if the values are different. So we could have put that logic in. I just wanted to keep it a little bit simpler for the example. So this will fire the change only when the value really changes. So now when I run my person sample, I'll see that at the end of this, both of their addresses have been changed. And the only one that I explicitly called out was Mike. So this gives you an idea of some of the synchronization type of capabilities you can get out of this. And this is something you do very commonly if you have some kind of graphical user interface, where you have the model and you have the little GUI component, and you have them listen to each other to keep themselves in sync. Make sense? Okay. Now there is something, because these property changes were so common. We'll see that this code here you're going to have in pretty much every one of your Java beans. They came up with a little helper class. Whoops.